A satellite dish works like this. You've got some satellites in orbit around the Earth, and they send signals down, for example, like cell phone calls. They send signals down, and those signals come in like this, like very straight lines, like so, and they're coming down from outer space. And when they hit this satellite dish, the curvature of the dish is going to bounce these things, so they all bounce towards that receiver right there. That's what makes a parabolic dish kind of useful. And then the receiver, then, on this tiny little chip, receives signal from a very wide area. And the bigger your satellite dish, the more signal it can focus on the receiver. That's the basic idea. Now, the question in this problem is, where should the receiver be placed so that it is at the focus? Okay, that's where a receiver is most useful. It's at the focus of a parabolic dish. So I want to know, essentially, what is the focal length? Okay, remember the focal length P of a parabola? Let's make an equation for this. And if you remember, here's the equation of a vertical parabola. That's what we've got here. And I'll explain why it's not a horizontal parabola. It's not a horizontal parabola because it looks like a vertical one. Okay, it's pointing up. You can imagine a coordinate system here. Let me just draw a quick coordinate system. You can imagine a coordinate system where that's the y-axis and this is the x-axis going across. Maybe I could do a little bit better of that. There we go. Okay, so see, the vertex of this parabola is located at the origin of this coordinate system. And the nice thing about that is I don't need to worry about h and k. The vertex is located at 0, 0. So this equation simplifies to x squared equals 4p times y. Well, now all we have to do is plug in some numbers to figure out what p is. I don't know what p is, but we can figure that out pretty easily. So let me clear some room here. Let's plug in, and no, you know what? I want that x coordinate, y coordinate plane. Let's take this point right here on the edge. Okay, if you think about what is the x location, that's going to be half of this distance right here. That distance is 22 feet wide. Well, then this will be 11 feet to the edge of the dish. And how high is that point? Well, okay, it's 4p. I don't know what p is, but I do know the height of the dish is 9 feet. So then I can say, what is p? Well, that's just going to be 11 squared divided by 9 equals 4p. And, you know, that's going to be something like, I don't know, 121. 121 on top, divided by 4 on each side, that makes this 36. So 121 over 36 is p. Well, where should my focus be located? Focus is a distance of the focal length. That's p. So here we go. This is our answer. P right there. Remember, this distance is p from the vertex to the focal point of a parabola. And that's all there is to this problem. I think drawing the xy coordinate plane is very, very useful, and especially recognizing that this point right here is an xy coordinate point that must satisfy the equation of the hyperbola.